Okay, we're going to start section 2.3 now. A couple of terms here to start. Definition: the intersection of two sets A and B, denoted by A intersect B is how you read that, is the set of all elements that are in both sets. The union of two sets A and B, denoted by A union B is how you read that, is the set of all elements that are in either set A or in set B. Okay, or both, set A and B. As a note, the word and is sometimes used to indicate intersection, and the word or is sometimes used to indicate union. You see that quite a bit in like statistics, but for now we're gonna use the intersection union signs. We'll see that more in the next section though. The word and or being used. Okay. So problem 29 is where I want us to shade the region on the Venn diagram that represents A intersect B, and then shade the region on the Venn diagram on the right that represents A union B. Okay, so intersection is where I want to shade everything in both the sets. Okay, so A and B, A intersect B means the same thing. Here's what that represents. Now, A union B is where I want to shade everything in A, or everything in B, and everything in A and B. Okay, A union B, here's what that represents. Okay, so problem 30, perform the indicated operations to determine each set. Okay, so the set containing 2, 7, and 8 intersect the set containing 2, 4, 6, 8, and 10. Okay, intersection means that you're looking at all the elements that are in the two sets. Okay, so I see 2 is in those two sets. 8 is also in those two sets. Okay, so the set containing 2 and 8 would be my answer. Okay, part B, the set containing 2, 7, and 8 intersect the set containing 1, 3, and 5. Okay, intersection, again, that means that you're talking about all the elements that you see in both the sets. Well, there's no elements that I see in both the sets together, so this would contain a set with nothing in it, and the empty set is the symbol that we use for that. Okay. Part C, the set containing 2, 7, and 8 intersect the empty set. Okay, so intersection means I'm talking about the two sets together, and any element that I see in both the sets. Well, if one of the sets is the empty set has nothing in it, right? So the answer is going to be the empty set. Okay. Part D. You got the set containing 2, 7, and 8 union the set containing 2, 4, 6, 8, and 10. Okay, union means that you're going to combine everything from the two sets. Okay, so if I combine these into one set, I got the set containing 2, 4, 6, 7, and 8, and 10. Okay, now the thing to notice here is that notice that union and intersection are two different operations. Okay, you're going to get two different answers with the different symbol there. Okay, and the set containing 2, 7, and 8 union the set containing 1, 3, and 5. Well, again, union means that you're going to combine the elements into one set. Okay, so I got the set containing 1, 2, 3, 5, 7, and 8. Okay, and then close up the set. Part F, the set containing 2, 7, and 8 union the empty set. Okay, so if I join in nothing, I'm not adding anything extra to the set containing 2, 7, and 8 by joining in nothing. So I'm going to still have the set containing 2, 7, and 8. Okay. Notice how these two sets are going to be different. Okay, again, intersection and union are two completely different operations. Okay. Problem 31. Okay, I got the universal set containing the set 1, 2, 3, 6, 8, 9, and 13. And then here's three sets that are in the universe. And I want to perform the indicated operations to determine each set. Okay, so part A complement intersect B. Okay, A complement is everything that is not in A but still part of the universe. So everything that is not in A is the set containing 8, 9, and 13. Intersect B. Okay, so B, I've just written that again. Now, intersection means that you're talking about the elements that you see together. And 9 is the only element that I see in both the sets together, so the set containing 9 is going to be my answer. Okay. Part B, I got B complement union C complement. Okay, B complement would be everything not in B. Okay, so the set containing 1, 3, 8, and 13 are all not in B. Union C complement, that's the set of all elements that are not in C. So the set containing 2, 6, and 8, those elements are not in C. Union means I'm going to join together as one set. So I got the set containing 1, 2, 3, 6, 8, and 13. Okay. Part C is A intersect the quantity B union C complement. Okay. Now, you'll notice that I got parentheses here around B union C complement, and where I've got parentheses means do that operation first. So I'm going to handle the intersection of A at the very end. Okay. I need to compute B union C complement first. Okay, so I'm just going to write A down. Intersect B union C complement is I've already got C complement right here listed. Okay, so now I'm going to union these two sets together. So I'm going to join together as one. And here's set A. Okay, intersect the set containing 2, 6, 9, 8, and 9. Okay. Now intersection means that you're looking at all the elements in both sets. Okay, so the set containing, let's see, what do I see in both the sets together? 2 and 6. Okay, so the set containing 2 and 6 would be my answer to that one. B union C, the complement of that. Okay, so, well, let me compute B union C first. Here's B, and here's C. Okay, now union means you're going to join together as one. So I got 1, 2, 3, 6, 9, and 13. Now I got the complement of that set. So everything in the universal set that is not these elements would only be the element 8. Okay, so the set containing 8 would be my answer. I'm going to note here, notice that my answers for part B and part D are different. Okay, that'll usually happen. Okay, so B complement union C complement is different from B union C complement. Okay, we'll talk about De Morgan's laws later on in this chapter, but okay, part E, A complement union C complement intersect B complement. Okay, so A complement is right here, set containing 8, 9, and 13. union C complement, so C complement is the set containing 2, 6, and 8, intersect B complement. B complement is the set containing 1, 3, 8, and 13. Okay, so I've got the complements all computed. Now let me handle these operations. Again, do what's inside the parentheses first. Now, I'd be doing this left to right anyway. Okay, so I'm going to be union these two sets first, anyway, and then intersecting them second. So when I union these two sets inside the parentheses, okay, union means that you're going to join together as one. So you're going to have the set containing 2, 6, 8, 9, and 13 intersect. I've just written this set again, so it's B complement. Intersection means that you're looking at all the elements that are in both the sets, okay? And so what do I see in these two sets together? Here's 8 and 13. So the set containing 8 and 13 would be my answer. Okay. Let's see, so the next thing is the definition. The difference of set A and set B is the set of elements in set A that are not in set B. Okay, problem 32, shade the region on the Venn diagram that represents A minus B, okay, which is this definition up here. Okay, so anything in A that is not in B, okay, so I've got that shaded, that'd be A minus B. Problem 33, I get the universal set, which is the counting numbers 1 through 10, and set A, set B, and set C are all part of the universe there. And I'm supposed to perform the indicated operations to determine each set. Okay, so A minus B. So I've written down set A. I've written down set B. Here's A minus B. Now, again, A minus B is everything in A that is not also in B. Okay? So let's see, 3 is in A, 3 is in B, so and I'm removing B, so I'm no longer going to see 3 there. 4 is in A, 4 is also in B, and I'm removing B, so I'm no longer going to see 4 there. 5 is in A. I don't see 5 in B, so 5 is going to stay. Here's 6. I don't see 6 in B, so 6 is going to remain. 7, I'm removing a 7 though, so 7 is not going to be there. And here's 8, and I don't see an 8 in B, so 8 is going to remain. So in all, I've got the set containing 5, 6, and 8, which would be the answer. Now, part B, suppose we want to compute B minus A. Okay, so that's where I've switched the two sets there. Here's B, and here's A. Okay, so same thing. Now I'm looking for everything that's in B, and I'm going to subtract everything that I see also in A. Okay, so 3 is in B, 3 is also in A, so I'm no longer going to see 3 there. 4 is in B, 4 is also in A, so I'm no longer going to see 4 there. And 7 is in B, I see 7 in A, so 7 is no longer going to remain. So I end up getting, and I'm removing other things too, that's fine, but with subtraction, you're always going to start off with the set that is written first, okay, and you're going to keep track of what's in there and what's not, okay, so everything in B got removed, okay, so I'm going to end up with a set with nothing in it, or the empty set. A note, notice that the results in part A and B indicate that in general, A minus B is not the same as B minus A. Okay, now that's different from intersection and union. A intersect B is the same thing as B intersect A, and A union B is the same thing as B union A. Okay, not subtraction though. Okay, these are different sets. Part C, suppose I want to compute A intersect B complement. Okay, so here's A. Intersect B complement means that you're talking about everything outside of B. So that'd be the set containing 1, 2, 5, 6, 7, not 7, 6, 8, 9, and 10. Okay. Intersection means that you're looking for all the elements that are in both the sets together. So let's see, I got the set containing 5 can be seen in these two sets. Here's 6, and here's 8. Okay, so I'm going to end up with the set containing 5, 6, and 8. Now, there's a note there. Note, in this example, we see that A minus B, which is the set containing 5, 6, and 8, is equal to A intersect B complement, which is the set containing 5, 6, and 8. In general, that will be true. Okay, so you're basically saying the same thing, right? A minus B is everything in A that is not also in B. Well, everything in A and not in B. So I haven't said anything different there. In general, that statement is going to be true. Okay. Let me stop right there in the notes.